about to see in these videos was all conducted at the University of Alberta's PSURF laboratory. PSURF is the Protective Clothing and Equipment Research Facility, and it's one of the foremost flash fire laboratories in the world. The testing is all done to the two relevant standards, which are the ASTM F1930 and NFPA 2112 standard. They're very closely related with regard to this research. ASTM F1930 talks about how to do mannequin testing, so that mannequin testing done at one lab, if it's done properly, should be the same as mannequin testing done at another lab when the standard is followed. The testing itself requires a mannequin with in excess of 100 thermocouples. They're able to detect heat transfer and the depth of that heat transfer, and therefore predict the exact extent, severity, and location of any body burn injury that would result from one of these flash fires. These flash fires are created using propane and torches. Flash fires are targeted at 2 calories per centimeter squared per second of average heat flux over the surface of the mannequin. The mannequin can then be dressed with various fabrics, flame resistant or non-flame resistant, and among the flame resistant fabrics, again, you're going to get a prediction of the extent, severity, and location of the burn that results. But that's not a pass-fail standard. ASTM F1930 tells you how to do the testing, but not what to test for. The NFPA 2112 standard picks up where ASTM F1930 leaves off. 1930 tells us how to do the testing. 2112 then applies that testing in a pass-fail manner. You get various coveralls where the only variable here is the fabric that's used to make the coverall, and you're able to compare directly one flame-resistant fabric performance to another. The coveralls are size 42 regular, and you do 3 replications at 3 seconds of flash fire duration, and if you have 50% body burn or less, you pass the test. These tests are conducted at 3 seconds because both the NFPA and the CGSB, the two organizations who have defined flash fire, define it in essentially the same way. A diffuse fuel in air, a moving flame front, and a 3-second duration. Westex recently conducted experiments outdoors at a major independent fire lab to look at flash fire duration. Preliminary results of this testing clearly show flash fires lasting a maximum of 3 seconds. The testing you're about to see shows a number of different fabric blends and fabric weights. One of the things that you'll notice is that all of these fabrics are compliant to the standard. However, they comply with very different numbers. You can comply at 49% body burn or at 1% body burn, and that's an enormous difference. It's critically important that when you're evaluating flame-resistant fabrics for potential use in your program, that you won't consider anything that doesn't pass the standard. The body burn silhouettes that we're putting up are, of course, specific to each of these individual tests, but because what's reported is an average of 3 replications, the number that you're hearing may be slightly different. This mannequin is wearing a Westex Ultra Soft 9-ounce coverall. The flash fire is over. There's no after flame. There's no visible garment degradation, shrinkage, either vertical or radial. No damage really at all. When we examine this exposure, again in slow motion, we see that when the torches go out, the fire goes out. It's instant. There is no after flame of any kind on this garment, and there's also, again, no visible garment degradation, carbonization, or shrinkage. The body burn percentage for this fabric, the 9-ounce Ultra Soft, is about 9% in this test series, which again is excellent because this garment not only doesn't ignite and support combustion, but also insulates to the hazard as a single layer, hence the excellent body burn percentages. When we examine this garment after the exposure in close-up, we see that there is no shrinkage, either radial or vertical. There's no visible carbonization. There's no visible garment damage at all. This garment really still looks like we could wear it to work again, looking the same as it did going into the exposure. As you can see, when this garment is removed, the t-shirt underneath the coverall is still white. There is no damage to it of any kind, and thus we can see that the fabric not only didn't support combustion, but also insulated as a single layer to this hazard, hence the excellent body burn percentages. Here's the body burn silhouette for the Westex Ultra Soft 9-ounce coverall, and as you can see, it averages about 9%. 7 or 8% of that is the head and neck, which are censored but uncovered, so there's little or no body burn through the coverall. This garment is a 6-ounce Nomex 3A coverall in a 3-second flash fire 2112. Torches are lit, you have a 3-second flash, the torches go out, and there's some after flame on the garment, but the good news is it does self-extinguish. This garment is flame resistant and will save your life by not continuing to burn after the initial exposure is over. Now, there was some after flame and there was some significant garment degradation, and we can take a closer look at that. The garment is going to be shrunk both vertically and radially, and if you take a close look at the leg and the cuff area, you're going to see both of those phenomenon. You have some dye sublimation where the garment is pink instead of blue, complete dye sublimation where the garment is khaki instead of pink, and carbonization where the garment is orange peeled or even more dark than khaki. If you look at this and you suppose that the afterflame and or the garment degradation might have contributed to burn injury, you're right. The body burn data for this garment averages 34% second and third degree burn. The majority of that body burn occurs in areas not covered by the underwear, the arms and the legs, because there's only one layer, and that one layer, while it does not burn, to support combustion in air, also does not insulate adequately to this hazard. So we can clearly see the value of the second layer when we remove the coverall and see that the t-shirt is badly degraded. Enough thermal energy has gotten through the single layer portions of the coverall to char the underwear as well. And the coverall has to be cut off of the mannequin because of the shrinkage that occurs, makes it difficult or impossible to remove normally. So the University of Alberta people cut some or all of the back to be able to remove the garment. And there you can clearly see where there were 2 layers in the pocket area, where there were 2 layers in the placket and zipper area, the t-shirt is undamaged. Where there was 1 layer of the FR coverall, you have an excellent illustration of the fact that while it doesn't burn, it also doesn't insulate adequately for that hazard. Here's a body burn silhouette for the Nomex 3A 6-ounce coverall, and as you can see, the average is right around 30%. The leading products in the marketplace are Westex Ultrasoft and DuPont Nomex. We've looked at several different weights of each of these products individually. Now, let's look at them side by side. The slow motion video gives us another excellent opportunity to take a good look at afterflame and garment degradation. The visual performance is only part of the story. Let's take a look at the data. The body burn average for the Ultrasoft 9-ounce was 9%. The body burn average for the Ultrasoft 7-ounce was 14%. The body burn average for the Nomex 6-ounce 3A was 30%. And the body burn average for the Nomex 4.5-ounce 3A was 38%. But not all flash fires last 3 seconds. In fact, the vast majority aren't anywhere near that long. So it's very helpful to have data for durations less than 3 seconds, and those are best viewed on a graph. The data begins when measurable body burn through the coverall begins. We start to see measurable body burn under the Nomex garments at 1 second or 1.5 seconds, depending upon weight, but not yet under the Ultrasoft garment. As we go out in time to 2, 2.5, or 3 seconds, you see the body burn steadily increasing through the Nomex, but no body burn through the Ultrasoft garments until 2.5 or 3 seconds, again depending on garment weight. The fabrics represented on this graph are all compliant to NFPA 2112, which requires less than 50% body burn at 3 seconds. However, it's easy to see that there's a vast disparity among otherwise compliant garments. You can comply with 49% body burn or 1% body burn. Both would comply, but have dramatically different implications for the person wearing the garment. So it's easy to draw the conclusion that compliance alone is not enough. It is critical to look at the data beyond compliance and pick the product that is best suited for your employees and your hazards.